Let's take a look at this problem. Our first example, we got 18x times x squared plus 5 to the 1/4 power plus 6 times x squared plus 5 to the 5/4 power. First off, let's talk about the groupings here. This is considered one group, and this is considered one group. The reason why these are considered one group is because everything inside is multiplication. This is 18 times x squared plus 5 to the 1/4. So everything's multiplied together. This one is 6 times x squared plus 5 to the 5/4. So again, everything's multiplied together. And the plus is what separates them. So as I look at these groups, first thing I'm going to do is look at the numbers. So we got 18 is 6. GCF of that, largest number divides in both of them is 6. So I'm going to be able to factor 6 out. Now this one has x to the first power, but this one doesn't have x to a power, so I can't bring any x's out. Now here we got an x squared plus 5 to a power, and here we have an x squared plus 5 to a power. We can factor out an x squared plus 5 to a power. Now how to determine which power to factor out? You always go with the smaller exponent. So we're going to bring out the 1/4. Okay, let's see what that gives us. 18 divided by 6 is 3. This x is staying inside. This x squared plus 5 to the 1/4 is gone. So that's what we brought out right there. Plus, that 6 is gone. We took that out. And here we have x squared plus 5 to the 5/4, and we took x squared plus 5 to the 1/4 away. Well, to decide what's left, you're going to subtract the exponents. So that's 5/4 minus 1/4. Now, if it matches exactly, see how it matched exactly here, then you just take it all the way. But if you have 5/4 here and then you bring out 1/4, then you subtract them to see what's left. So then we got 6 times x squared plus 5 to the 1/4. Here we got 3x plus x squared plus 5. 5/4 minus 1/4 gives us 4/4. So we got 6 times x squared plus 5 to the 1/4. 3x plus 4 over 4 is 1. So that's like x squared plus 5 to the first power. And then we got x squared plus 5 to the 1/4. 3x, the first power doesn't do anything, so just drop it. And the last thing I'll do is rearrange those so they're in standard form. So we get x squared plus 3x plus 5. Now normally we might try to factor this, but as you can see, nothing will factor in that, so that would be our answer. Now let's take a look at a slightly tougher one. One of you might think, well, I can't factor anything out of that. Let's see, 4x squared, x plus 3 to the 2/3 power. And then, I don't know, plus 12x to the 5th, and x plus 3 to the 1/5 power. First off, let's identify our groups. This is considered one group, and this is considered one group. And the reason why is because everything's multiplication. This is 4 times x squared times x plus 3 to the 2/3. This is 12 times x to the 5th times x plus 3 to the 1/5. So the numbers we're going to be okay on. The x to a power we can handle. But there's something wrong with these. If you look at the exponents do not have the same denominators. Well, let's get the same denominators. So I got 4x squared, x plus 3. Now our two denominators are 3 and 5. So our LCM of those would be 15. Easiest way to get a common denominator, though not necessarily the smallest one, is to multiply them together, 3 times 5. So we're going to rewrite each exponent with a new denominator. Now in this first fraction here, I multiplied the bottom part by 5, so I have to multiply the top part by 5. So that would be 10/15. plus 12x to the fifth, x plus 3, and again we want to rewrite them both with the same denominator. Now in this one I multiplied the bottom part by 3, so I have to multiply the top part by 3. Okay, now let's figure out what to factor out. Let's look at the numbers first. 4 and 12. GCF, those is 4. Largest number divides in both of them. Now we got x to a power and we got x to a power. Now you always want to bring out the one with the smallest exponents. So we'll bring out an x squared. And then we got x plus 3 to a power and x plus 3 to a power. And again, we always want to bring out the one with the smallest exponents, which in this case is the 3/15. Okay, now let's see what's left. That 4 is gone. These x squareds are gone. Here we got x plus 3 to the 10/15 power. Remember, to decide what's left, you're going to subtract the exponents. So I'm going to take the 10/15 minus the 3/15, what I just took out. This right here. Plus 12 divided by 4 is 3. We had 5 x's. We took 2 of them away, so that leaves us 3 x's. And here is x plus 3 to the 3/15. We took all of that out. So that's completely gone. Okay, so now we got 4 x squared, x plus 3 to the 3/15. And then inside we got x plus 3, 10/15 minus 3/15, since they have the same denominators. 10 minus 3 is 7, so we got 7/15. Plus 3x to the third. Now that's as good as it's going to get for factoring, because there's no way this simplifies down further. When I make these problems up, I cannot get them to come out nice like that problem up above. You know, where everything works out good here. Anyway, that gives you another example of how do you handle it when you have different denominators in your powers.